This is a quick walkthrough of the midterm practice problems. Number one, verify that this given function y equals to c times e to the power of negative x cubed satisfies this differential equation. In order to verify that this function satisfies the differential equation, you have to figure out first what y prime is, because since y is c times e to the negative x cubed, you have to figure out y prime by using the chain rule. The chain rule says this inside function has to be pulled outside. No, this negative x cubed, the inside function has to be pulled outside and differentiate, which gives you negative 3x squared, and that's how you get y prime. Now replace this y prime by the given, the obtained function here, and then y by c times e to the negative x cubed. Then you just calculate. After you calculate, you see that everything becomes 0, which is indeed what you have on the right side. Since the left side do agree with the right side for this given function, we know that this given function is indeed a solution. In order to find out what c is, you need an initial condition. The initial condition given to us is y of 0 equal to 7. So let's see what that does. Y of 0 is equal to 7 means that when x is 0, y is 7. So we take this given function, we plug in 0 for x, just like this, and figure out what y is. We see that y is equal to c, but wait, y of 0 should be 7, so y of 0 should be 7, so c should equal to 7, so our answer is c equal to 7. Second question. Here we have a direct integration problem. The way you solve direct integration problem is you just integrate both sides, and since y prime is on the left side, when you integrate you just get y, which is indeed what we are looking for. So all we're supposed to do is to figure out this integration on the right side. And this integral, by the way, will be hard to do without any given formula. The problem here gave us the formula to use. It says to use the formula cosine 3x is equal to 4 cosine cubed of x minus 3 times cosine of x. Now, if you look at this integral, you see that there's a cosine here, another cosine here. So if you took u as cosine, if you did a u substitution with u equal to cosine, then because the derivative of cosine is negative sine, this sine of x, it will eventually cancel away, leaving you with just a pure integration of u with respect to u. Some function of u integrated with respect to u. Hopefully everyone knows how to do u substitution, so I'm not going to explain in any more detail. If you do this integral, you end up with this function here, and since the left side is y, indeed we get the general solution y equals to this function here. However, we are also given the initial condition, which will give us a clue for figuring out the value of c. So let's do that. Since when x is 0, y should be 1, we plug in 1 into y, like this, and 0 into x. And if you set them equal to each other, you get 1 equals to this thing here coming from this function here. And then after that, if you solve for c, you get c equals to 1/2. And the final answer is this. When you get the value of c, you should put it back into your solution to finally get the answer with c replaced by the value that you found out. The reason in the previous question we just stopped at here c equal to 7 is because the question was just asking for the value of constant c. But usually when you get the c, you should always go back and put into the function so that you get the answer for the differential equation. You get the specific solution of the differential equation. Question 3, we have a word problem. The brakes of a car are applied when it is moving at 100 kilometers per hour and provides a constant deceleration of 10 meters per square seconds. How far does the car travel before coming to a stop? Now, you notice that we have kilometers and meters, 2 different units for distance, and hours and seconds, 2 different units for time. That's not good. You should change so that you have a single unit for each physical quantity. So let's stick to meters for distance, so the 100 kilometers is 100,000 meters, and also seconds for the time, so that 1 hour is 3,600 seconds. Therefore, 100 kilometers per hour can be changed into 100,000 meters per 3,600 seconds, which calculates to 27.78 meters per second. Now, if you read back, it says the speed of the car was when the brake was pressed. So initially, when the brakes were pressed, the velocity is exactly 27.78. However, there's a deceleration of 10, meaning that the acceleration is negative 10. What's the relationship between acceleration and the velocity? Acceleration, as you know, is the derivative of the velocity, so we know that velocity prime is negative 10. And that's good because we can figure out what v is by integrating v prime. And we get negative 10t plus c from that. And then we can use this initial condition v of 0 equal to 27.78 like this and get the value of c, giving you the velocity in this format. Now let's read on. How far does the car travel before coming to a stop? We know that the car stops when the velocity reaches 0. So we take this equation, put 0 for v and solve for t to figure out that the car stops after 2.778 seconds. And then in order to get the position, see, we need to know how far the car travels, so we need to know the position. To get the position, you integrate the velocity because velocity is the derivative of the position, and therefore position is the antiderivative of the velocity. So we integrate this and we get this answer, and you put this 2.778 into here to figure out how far the car moved from the position it pushed the brakes in. And the answer you get is 49.39 meters. Number 4, a roast initially at 50 degrees Fahrenheit is placed in a 375 degree oven. At 75 minutes it's 125 degrees. And how long would it take to reach 150 degrees? Okay. Now, the Newton's law of cooling says the rate of change of the temperature is some constant times the difference between the ambient temperature to the temperature of the object. So we get this differential equation. This is a separable differential equation with the variables t and capital T and small case t, lowercase t. So we divide 375 minus t to this side, and we multiply dt to the other side, and we integrate. Now, if we take the integral of both sides, we get this integral here. An effective way to do the integral of this is to use this formula that if you have f prime over f, if you integrate it, you get log of the denominator. It's a very useful formula. You probably want to use it as much as possible. Now, in this form, it's not f prime over f, because if you differentiate the bottom, 375 is a constant of 0, negative t differentiates to negative 1, so it's not negative 1, you have 1 here, right? So what you do is you want to put a minus in front, and put a minus here, so they balance out, and indeed these are the same. But this is better than the previous one because this is f prime over f type. The top is the derivative of the bottom. In that case, the integral is the log of the denominator, so this is what we get. We get the log of the denominator. On the right side, we get kt plus c. And then we solve this. It's just algebra. You move the negative to the other side. To cancel the log, you raise it to the power over e, and e and ln cancels, and you solve for t. This is what you get. And then since the roast was initially at 50 degrees Fahrenheit, that means the temperature at time t equal to 0 is 50. Using that, we can figure out what c tilde here is. And then to find the k value, we use the next data, which says at 75 minutes it's 125, so put 75 and equal to 125. That gives you the value of k. Put the k back here, and we get the equation for t, right? Now, what are we looking for? We are looking for the time t, the lowercase t, when this capital T, the temperature, becomes 150, right? So replace capital T by 150 and solve for T. It gives you that it requires 105 minutes from the time that the roast was put in to the oven. So the answer is 105 minutes. And if you want to know how long after the 75-minute mark you have to wait, it's 30 minutes more. Okay, so wait 30 more minutes and the roast will be medium rare, good to eat.